I have finished easy spin pulse motor running on 0.7 volts aluminum carbon battery. It can run from half volt and consumes less than 20 microamps. So I got microwatt motor, 10 microwatt motor, and power goes into friction of Saphire bearing. Coils, total resistance 12 coils in series, 6 kilo ohms, one coil about 500 ohms. Voltmeter. From year 1956 voltmeter, there is jewel bearing. I will put this jewel bearing inside the hole. Rotor supported on a needle and two Saphire bearings from analog voltmeter. Spins for more than 15 minutes freely. I found old wire from Soviet times, 0.07 millimeters. One successful and several half done. Not enough hands to show you the process. So the spool is on ball bearings and I wind much faster. Just with one coil, half milliamp, half volt, 1.5 volts, 0.9 milliamps. Needle in the Saphire bearing. Coil resistance is 480 till 570 ohms. This is how it runs with two coils. Checking poles with a magnet compass. It took 2 days to assemble easy spin motor. One day was to 3D print and find Saphire bearings, and second day was to wind coils. This is how it spins on 15 volts. There is some wobble. Trace on oscilloscope. Motor runs from 4 volts, but the spikes are maybe 50 volts. Optimized read switch position for lowest voltage of operation, 0.5 volts. To my happy astonishment, it spins this slowly also the next day from 0.5 volts. With read relay, with transistor circuit would need the germanium transistor probably. The current shows step between maximum value and half value, and I think this step is due to induction, self-induction. Adjustment of read switch position. If the switch is far away, we want a short pulse of read switch, that it's in correct phase. I also connected electrolytic capacitor across the ampere meter, and that smoothens the oscillations, and moving to optimal position gets smallest consumption. Got the lowest current consumption in such adjustment. Here the motor is running from half volt. The current is basically 20 microamps. If we decrease the diameter of the wire 2 times, then we can fit 4 wires in the area of the original wire. And 4 times less area per wire means it is having 4 times more resistance per length. And also we put 4 turns in the area which previously was just 1 turn, so again we get 4 times more resistance. So total result is 16 times gain in resistance if we go to 2 times smaller diameter. The current through the coil at slow motion, it's Ohm's law, voltage divided by resistance. Half volt divided by 6000 ohms, we get 80 microamps. But we have pulsing only quarter of the period, so we had 20 microamps consumption. Driving motor at 5 volts, we get spikes 40 volts by electromagnetic induction law. These spikes radiate energy and contribute to more losses. If I remove the power supply, we get sinusoidal signal on the coils. But if I look on the power supply connector, we get generator in action. So we can put electrolytic capacitor and charge it. Now we'll disconnect the flywheel and connect 1000 microfarads electrolytic capacitor to charge it from the flywheel. The flywheel slows down, the voltage goes up a little bit, and so we went to half volt. Next we will monitor what will happen if we leave 1000 microfarad capacitor to drive the flywheel. Well, apparently capacitor stores quite a lot of energy. The next test will be how long it can run from 1000 microfarad capacitor charge to 5 volts. It stops spinning after 3.5 minutes. Next test will be to disconnect power without capacitor. Without capacitor 1.5 minutes. Test with added Schottky diode to recover energy from spikes and recharge into capacitor back. Quite similar, get 3 minutes, maybe 4. Next test will be at double the voltage, 10 volts. To my big surprise, get only 5 minutes, not 4 times more as expected. So there is some friction increasing with rotation speed. Running from 1 farad supercapacitor charged to 0.85 volts. Half an hour later, 0.8 volts. Drop 60 millivolts. Runs from a solar rocker toy, solar battery 1.5 volts, very small solar panel. Trying to charge the supercapacitor using rotation with compressed air blowing. I think it is impossible. Effect of recovery diode across the reed switch. We put back some energy into a capacitor. Back-induced voltage can be used to pulse an LED, which pulse is very dim. That means not much energy is released. I have charged a tiny supercapacitor 0.1 farads to 5 volts and consumption is 200 microamps. It is possible to stop the toy to save the battery and then spin it again. This is the way how you can impress people. We can get motor spinning. And there are no cables or hidden batteries. But there is a hidden supercapacitor here. I got tired with that solar stuff. You come in the morning and the motor has stopped. Easier to put a battery. You can play with different batteries. Here is solar cell and battery from solar lamp. Now this looks more attractive when solar panel is on the top of the motor. And you can disconnect the battery and it continues to spin. Making a so-called crystal battery One electrode is copper and other electrode is magnesium, sacrificial electrode, and then there is Epsom salt, which is magnesium sulfide. And yeah, if one is doing electrolysis from salt, one can produce back magnesium, so it's a kind of rechargeable battery. Crystal cell voltage 1.3 volts. Running easy spin motor.